to the very first Wrobocon. I'm very glad to be here. It's a great honor for me to have a talk at the very first Wrobocon. I hope there is still much more Wrobocons to come in the future, and hope to see you also there. But let's get back to the topic of the presentation. So I wanted to tell you a story about the integration of robot framework and Ranorex, the tale of continuous research. The subtitle is about the continuous research, but there are many more levels of this story, but you will surely find out shortly. So lend me your ears and let the story begin. But first, before we begin the story, I would like to give you a bit of background of the industry this project, the story takes place. So it is in the printing industry. So when I first heard that our customer is from the printing industry, I imagined a printer like you see here. So a regular everyday printer that you can find in the office or at home, but I couldn't be much more wrong. Our customer produces printers like these. Actually, where is the printer here? Is it this? Is this the printer? Or is this? Yeah, the printer is here on the right side. So you here see several printing machines, and this machine by which the person is standing is a control panel that allows to control the printing process. So as you can see from the first picture and from this picture, printing industry is quite complex. It's when you have all the machines that are required to print, for example, a book, they can consume a lot of space. There are a lot of connections between the machines because one is printing, the other one is folding and the printed sheets, the other one is gluing them together. So like I said, very complex process. And our customer not only provides the printers and all other devices that are needed to get from a PDF file to, for example, a ready-to-sell book, but also the software that drives these machines. So software, for example, like we saw in the previous slide, for the control panel, but also software that manages the whole printing area and the whole process. Yeah. So what was the problem that we wanted to solve? Our system under test was a desktop Java application plus some distributed applications. And what was the situation as we were introduced to that project? And our customer already invested in Ranorex. So what is Ranorex? It's a commercial tool. It helps to automate desktop applications. So with the use of Ranorex, one can create a desktop automated test, and Ranorex provides a recorder. So a tester, for example, can record the actions that he is performing on the desktop application, and then by playing back this recording, the actions are taken again on the application. So this way, this is a way, among others, to create an automated test with Ranorex. So, but although the investment in the Ranorex, the return of the investment wasn't as big as expected. Yeah, the thing was that there could be only one type of test performed, and that was end-to-end front-end test with no database test, no API test, and that was due to the lack of C# developers. Another issue was the number of available licenses, because there was only 2 licenses available. Yeah, and then it was challenging to share the license among the testers. What we wanted to achieve. First of all, the main issue that we thought about is the number of licenses, and that not every person can write a test. So when he wants to write a test, because, for example, the license is occupied by someone else. And the second goal is kind of combined, because we wanted also that non-technical persons that are subject matter experts in a specific printing domain can also write a test. So we wanted to be the entry threshold as low as possible and as seamless as possible from the non-technical subject matter experts, because sometimes convincing people to new technology can be hard, so we wanted to be, like I said, as seamless as possible. So we came up with a solution. Ranorex provides a .NET API in DLL files, so we used IronPython. It's an open source implementation of Python, which is tightly integrated with .NET. So we had the link between Ranorex and Robot Framework by using IronPython, and also we engaged the remote library just to communicate it to the distributed environment. And how does it look like on a diagram? So we have the test resources. I'll come back to the resources in a moment. And then we had IronPython. We had a library written in IronPython. The library also included a remote library. And with the help of remote library using .NET runtime, our library communicated to the Ranorex DLL files, and the Ranorex DLL files that are containing the API were conducting the test, so they were performing the actions on the system under test. Yeah, and it worked. The SMEs wrote test on a Confluence page. Yeah, it's maybe kind of strange and fun why on Confluence page and how. So, but the idea is very brilliant, and it's simple. So it's simply brilliant solution, because how did it look like? SME, a subject matter expert, wrote test on a Confluence page. The Confluence page was actually a table in which the SME wrote the steps of the test. And then we took those HTML files, downloaded them. With the help of RobotTidy, the syntax was translated to Robot Framework syntax, and this way we had ready to use tests. Another part was the Golang solution, the Golang application, that was that the main responsibility of the application was to take care of the dependencies of the environment. So it downloaded the Confluence pages and conducted the conversion from HTML files to a robot file. It also checked if IronPython is installed, if a library is installed, so if Ranorex is there also, so for all the dependencies. But it also had its downsides. IronPython was old technology. Even back then, it was over 2 years ago. So sunset technology is always a red flag, for example, for security concerns. And the same for Python 2.7. It's also old technology. And another issue was that the described deployment of the library was problematic. So it was time for a new solution. Around that time, the developer that was involved in the first solution had to move to another project, so a new developer come into play with new, fresh view on this topic, and he concluded that it's best to approach the Ranorex API from another angle. So the core stayed the same as it was. So we wanted to stay with robot framework, and we needed to go from .NET to Python. But this time we engage PythonNet. It looked promising and seemed easy to implement. And one thing that was missing was also a framework on which we could work. We decided that we will use a .NET framework, and some of you may wonder why not .NET Core. Actually, because back then Ranorex didn't support .NET Core, and also Ranorex needs an environment on which it can render images. So .NET framework fulfilled this prerequisites. So, and thanks to using PythonNet, we could switch from Python 2.7 to Python 3. So again, on the diagram, how does it look like? The test resources and system under test remain as they were. And yeah, in the middle, you can see that this a bit simpler diagram, because we have the library in Python, and this library now using PythonNet, which was a flexible API, connects to Ranorex DLL files where the .NET API is stored, and again the Ranorex DLL is taking action on the system on the test. And here is a code snippet with an example of a keyword from this solution. So it's a run application keyword. It has several arguments. Some of them have default values, and yeah, the docstring, and the main part of the core of the keyword is here. We are actually calling by the use of PythonNet, we are calling a function from the .NET API in Ranorex that is called runApplication, and are passing the arguments to that function. And based on this pattern, we created some basic keywords like click a button or drag and drop. And again, it worked, but creating and developing the library was quite complicated because, like you saw on the previous slide, all the keywords in our library were triggering a function from the .NET DLL API of Ranorex. So we had to import all these DLL files to our library. And yeah, other thing was that the Python and .NET framework didn't want to cooperate with each other. From at least the newest versions of both solutions weren't compatible, so we had to basically try and error search which Python version will cooperate with which .NET framework. Yeah, but we created some basic keywords for interacting with the desktop application, but yeah, as the basic keywords were ready, our so to say special forces developer who worked on it had to move to another project, and a new developer was introduced to the project. And by the time when she was getting familiar with this library and with Ranorex as a product, she stumbled on the information that Ranorex is planning to create a Ranorex driver. So after researching the topic of Ranorex driver, we decided to go for it. So it was time for the solution 3.0. As you can see, the technology stack is far more simpler than the previous solutions. So we had just a robot framework and Ranorex driver. So maybe it's a good time to say a bit how the Ranorex driver is working. It exposes a W3C WebDriver interface on top of Ranorex runtime, and as a result, Ranorex driver works with tests that are written using Selenium framework. So one might say that Ranorex driver is borrowing some of the functions from Selenium and makes them available for desktop applications. And yeah, how the solution look like. So we had Ranorex driver library, as we call it, and the library has the WebDriver in it, and the WebDriver from the library connects to Ranorex driver, which contains this API, and the Ranorex driver is performing operation on the system under test. And I brought a code snippet with an example how the Ranorex driver is set up. So we have a WebDriver remote, then is the address of the remote when we have where we have the WebDriver, then the browser name is Ranorex, and then there follows a few options from Ranorex. For example, the application that we want to test, if there are any additional arguments that we want to pass them, force flag set to true restarts the application. So if the suit is started, this flag forces it to restart. And whitelist of applications, the list of applications that that the driver can take into account. And I think it's a time for a almost live presentation. So here we have a code. And we import the WebDriver in it. And we define the Ranorex driver. So we set the remote, the browser name is Ranorex. The application we want to automate is calculator, so here's the name. And calculator has two names, actually, calc or calculator. In the whitelist we use them both. And yeah, what do we want to do with this test? We want to find number 2 button, and then after this we want to click it, then click several other buttons. We want to have the result of the math behind it, and yeah, then we want to store the result and print it. And finally, the driver closes the applications. So let's see how the scripts runs. The calculator opens. Here's the math behind it, and the result is 32. And as you can see, it's here printed as expected. And here's the same test, but written in our Ranorex driver library. So we import the library. Here are the locators of the buttons that we want to click, and yeah, also the display from which we want to have the result. In the setup, we open the application, so it's the name of the application, the location where it's stored. Then yeah, set automation speed for 1 second, because Ranorex can be very fast, so faster than a human eye. So we set the test automation speed to 1 second just to have a chance of seeing what is actually being performed. Then we have the click on the buttons, so the number 2 button, number 1, multiply then number 2, and then equals in the end. So we want to again catch the result and print it. And then in turn down we close the applications. So let's see how this robot test will work. So you can see that automation speed is 1 second, so it's waiting 1 second after each click. Yeah, and there you have it, the same result as in the Python code. And the printed value is 32. So what were the main benefits of this solution? First of all, it's simple. Yeah, it's simple because the technology of drivers, for example, Selenium, are widely known, so to say. So the entry level is easier, and yeah, we just need Python and the Ranorex driver, of course, the license for it. Easy to use selectors, so there are XPath-like selectors, but I come to the back again later. But yeah, there are easy to use selectors, and the Ranorex tools that make the whole automating process easier, because sometimes to get a selector can be hard, but there are applications. There is an application like Ranorex Spy, which helps you with interacting with the application. And the other thing, it's fast and efficient, so it's not that hard deploying and developing and extending the library as the previous solutions. Here I wanted to show you the Ranorex Spy. We want to track a button in application, so we just click track, then on the element that we want to track, and here you see the Ranorex XPath is being collected from the application. So with this XPath that was created, we can use it to interact with the application in our code, in our test. But everything also has its drawbacks. So first of all, Ranorex is a commercial tool, so you need a license for it, as I mentioned on the previous slide. Ranorex functions are limited compared to Selenium driver functions, so we started to hitting the limits of Ranorex driver. Getting the attribute values from an element, it's not always easy. It can sometimes be really hard, and yeah, we also are working on a solution how to make the process easier. And that part, the most annoying thing is that there is always the same error message. So no matter what is wrong with the Ranorex driver, the error message is always the same, and that makes the debugging process much harder. Ranorex needs a computer screen unlocked while doing the test, or it needs a RDP connection to a computer, to a machine on which the tests run. So we are also creating now a solution, a service that is creating the connections via RDP to computers on which the tests are performed. And the last thing, that Ranorex is only for Windows. So if you have the need to automate something on macOS, you cannot use Ranorex driver for it. Yeah, and if Wrobocon would take place about 2 months ago, that would be the end of a story. But luckily it didn't, and our story goes on. It's time for version 4.0. Why version 4.0? Because like I said, on the with the Ranorex driver, we were starting to hitting our limits. So we want to extend our Ranorex driver library with PyAuto GUI, which comes into play at that moments where Ranorex doesn't cope, and we have a remote library to connect to the applications. One other part that is worth mentioning in the solution 4.0, we are building on our previous solution. So when you remember in solution 1 and 2 and then 3, all of them were approaches from a different angle and started from scratch, so to say. But this solution, version 4.0, is building on our solution 3.0, and it's extending it. So how does it look like? It's actually pretty much the same as version 3.0, like mentioned just a second ago. Here is the part that you already seen, because we have the Ranorex driver library with the web driver, and it contacts with Ranorex driver, and Ranorex driver is conducting tests on the system on the test. And yeah, that was the solution 3.0. In our full solution 4.0, we have additional PyAuto GUI. So in PyAuto GUI, with the use of remote library, is connecting to the system under test and performing those actions which Ranorex driver cannot do. And now an example of the Ranorex driver library 4.0 with the enhancement of PyAuto GUI. So we download the library first, and then we in the variables section we have the locators with which we want to interact, and then in the test itself, in the setup, we open an application. The application is Ranorex demo app. So it's an application you can download from the Ranorex page. It's provided by Ranorex, and it can help you get a feeling how does Ranorex interact with an application. So if you want to try it out, the Ranorex demo app is the best place to start with. So in the test, then we want to get the title, and then we will move to, and the move to keyword is using a screenshot of an element to locate it. So it's interacting with a screenshot. And we then want to move to the reset button, and we have the screenshots of this both elements here. And then we want to send a key sequence. The key sequence is Chris, and the enter your name field is the place you want to send it to. Then we have an element click based on image again, so we can click basing on image. Then we change the tab and perform a right click on the element. And then we again change the tab, and this time in the new tab we will do a double click on a tree element, and then the application will close. So let's see how the test works. The application is open. We move to the submit button, reset button, no hands. Yeah, then the send key, click submit, the welcome text change. Then we change the tab, here the right click. And we will change the tab again, yeah, and perform double click on the tree element, and the application will close. So that is a quick glance what the version 4.0 can do. So we engage Pyauto GUI to extend the possibilities of our application, like mentioned before. Taking about a glance, we can take a glance in the future also. What we want to do is also to have a solution for macOS operating system. So we have to perform the same tests on the Apple environment, and yeah, we are looking for a solution for that. Luckily, the power and beauty of Robot Framework is that everything apart from GUI automation we can reuse from our current test set. Yeah, and maybe you're wondering about open sourcing the library. So unfortunately for now we cannot open source the Ranorex driver library, yeah, because we still need to obtain the consent from our customer. So thank you for listening. I hope that you enjoyed this presentation. Again, it was a great honor for me, and yeah, see you in a second in the live Q&A session. Yeah, and by the way, I'm Chris, for the Polish speakers, Krzysiek. Thank you, and see you soon.
So please welcome Krzysztof live for 5 minutes of Q&A. We have some interesting questions this time. First of all, Ed Manlove is asking, is there an overlap in the keywords for your Ranorex driver library and other Windows application libraries?
Yeah, yes, I think so, because the keyword that we write, yeah, are self-explanatory. So the keywords like click an element and get a text from an element, and such keywords, they're probably named the same way. So it's probably overlapping. Yeah.
Okay, there is also second part of the question. Can you easily switch between Windows app libraries?
Yeah, the version 4.0, we are a part of using Ranorex WebDriver. We are using also Pyauto GUI, so there are basically two libraries behind that. And yeah, probably when we want to extend to other systems, it will be probably also possible.
All right. So can you use the XPath selectors directly from the helper application that you demonstrated just directly, or does it need some adjustment or intermediate step, or do you have to escape those selectors in some way?
No, actually it was it's quite easy, like I mentioned. So when we identify an element, so we can use the selector that is generated by it directly in the code. So sometimes you can even make it a bit shorter, so cut off a little bit if you want to have a shorter XPath. But yeah, of course you have to check if it's still working. But yeah, it's easy to use. You can use directly the generated XPath from the SPY application.
Okay. There was also a question, how complex is the system that you are testing with this library?
Yeah, that was why in the presentation I presented how a printing factory, so to say, looks like. So there's many components, many hardware components and software that are driving this hardware and then interacting with each other. So yeah, I think it's quite complex because the application that we test has also communicates to other software. Sorry, getting the responses from them. So I think it's rather complex.
Okay. And last question from the community. Why wasn't the solution built with the Ranorex driver in the first place?
Yeah, it would be probably easier when it would be built from with the Ranorex driver at first. But yeah, like mentioned, when we just finished working on the solution 2.0, and we have a switch in the team of the person responsible, then we just saw that Ranorex was informing that they plan to release a web Ranorex driver. So at the solution 1 and 2, no Ranorex driver was available. That is why we had to think of another solution. And I think it's a good moment to close a door that I opened at the beginning of the presentation, because I mentioned that it's a tale about the continuous research, but there are many more levels to this story, not just the continuous research. And I think the second very important level of the story is teamwork, because the colleagues that were working on the solution were changing, and the teamwork worked very well. So based on the previous solution, we can go to another solution and think of some new ideas or approaches. And I think that helped a lot by developing the final solution that we have right now.
So you would say it's communication, right?
Yeah,
just like
exactly.
like Lina suggested in her talk. Okay,
yeah, exactly.
the 5 minutes Q&A session is now over. Thank you, Krzysztof, for your attendance and for your presentation.
Thanks.
It was very interesting. And right now we have a couple of minutes of break, and we will see each other in some 10 minutes at 11:25. There will be robot framework critique. So see you then, and bye-bye.
Bye.